Hi, I'm a master student majoring in computer science, and this is architecture comparison of ALU versus ALM, where we will be comparing an ALU and ALM. I know there's like very limited information available about an ALM, but if you're looking for some sources to check out, I've mentioned a couple of them throughout the slides. So let's get started. Firstly, let's discuss about the structure, the architecture of an ALU. On the right hand side of the screen, I've provided from where I've picked up this article and where you can get it from. So this is the internal structure of an ALU. You have your Cn-1, A and B, and depending upon how many types of, how many number of inputs you have, and then you have your select lines S0, S1, S2. They can be more, they can be less, depending on how complicated or how simple your ALU is. There are mainly two stages, which is the arithmetic stage and the logic stage. Depending on what kind of input is given and what select lines are selected. And once we have an output from either of these stages or both of these stages, it goes into the multiplexer, and then we get our final output, which is f of n. This is the circuit component for the arithmetic stage. So the arithmetic stage, okay, we'll go back. We have the arithmetic and logic state. We're going to go do a deep dive in both arithmetic first and then the logic state, and then we'll come with ALM. So with the arithmetic component, we have two full adders. If you don't know what an adder is, check out digital electronics, check out adders, multiplexers, and how they work. Or I'll shortly cover a video on them as well. But yeah, based on the select lines and the inputs, the circuit adds whatever input it receives before it goes towards the next stage or before it's sent towards the multiplexer after the output has been computed. The logic component is pretty simple. It is, again, it has another mux or a multiplexer, and yeah, based on the select lines, you have S0, S1 and your AB as output. And yeah, once the output is generated, it goes towards Fn. So that's it. Towards ALM, this is a little more difficult diagram to understand. It's a bit more complicated to understand. Instead of having a multiplexer, we have a D flip-flop that we're using as a register, and we do have multiplexers here. So these are multiplexers. We're using combinational memory here. And it says 8 data lines. It can be more, it can be less, and even though it says 6 here, 6 is as it takes into account select lines as well. You have your adders, goes into these registers, and then you have your outputs over here. Yeah, this is given by STATEX 4 ALMs. This is a high level background, and I believe this is the Ulterior plan for it. So do check that out. ALM is actually pretty difficult to understand if you're not going into hardcore electronics, but yeah, all you need to know from like an exam perspective is the difference between the two. So yeah, you have your D flip-flops, you have more adders, more multiplexers, and here LUT is lookup table, so it compares the output. So you already have, so 1 1 corresponds to say 1. So you have that lookup table already inbuilt, and it corresponds to whatever output has been already saved. And yeah, based on what the data it gets, it compares it with the lookup table before sending the data ahead. That is what an LUT is, lookup table. If you want more information, just look into that. But yeah, that's like the basic difference between an ALM and an ALU. It's almost the same, just that an ALM is a bit more complicated.